Namaskar and good afternoon, ladies and gentlemen. Once again, a very warm welcome back to the panel discussion session 1. The topic for this session is satellite ground segment technologies. The time duration is approximately 1 hour, and the topics which will be discussed in this session will be the underlying technology, multi-frequency operations, including optical software, defined networking, virtualization, standardization versus innovation, manufacturing and collaborations, cloudifications, and security, etc. So, ladies and gentlemen, eminent chairperson for this session is Shri Rathnakara, Director, Satcom Program Office, ISRO Headquarter. And our distinguished moderator for the session will be Mr. Gaurav Kharod, Managing Sales Director, Intelsat, India. Eminent panelists for the session are Mr. Jean-Luc Almeida from Thales Ground Segment and Services, Mr. S. Parameswaran, Planet Aerospace ex-director, MCF, ISRO, and Dr. Prasad Bhatt, Chairman and CTO of Astrome Technologies. And ladies and gentlemen, before I hand over to our distinguished moderator of this session, I have the privilege of introducing the chair and the moderator. The eminent chair, Mr. Rathnakara, Director, Satcom Program Office at ISRO Headquarter, was the key player in ensuring precise performances of payload with well-planned in-orbit tests. His contributions also include development of innovative solutions in tracking, monitoring, and operations of communications as well as NAV-IC satellites. And a very warm welcome to you, sir. And our distinguished moderator, Mr. Gaurav Kharod, is the Managing Sales Director for Intelsat for India and South Asia, is a satellite communications professional with 20 plus years in the satellite industry. He has worked across different satellite service providers like Hughes, Viasat, and Intelsat, an industry veteran across satellite networks and media applications domains and gaining new experience in the maritime and IFC domains. And a very warm welcome to you, sir, and over to you to kindly carry forward the proceedings of this session. And may I once again remind the time duration is approximately 1 hour.
Thank you, Sapnaji. Being the moderator of the panel, I'll take the lead here first, but my request would be for Mr. Rathnakara, the session chair, to take over the initial floor and start the proceedings on this panel discussion. Mr. Rathnakara, please.
Thank you, Gaurav. Anyway, at the outset, I would like to extend my sincere appreciations to SIA-INDIA for having chosen this very relevant topic. So far, the Satcom ground segment industry has not made a significant impact in India. It is the high time that the industry gives a thrust in this sector also. Today, we are seeing satellites are embracing with the digital processors, software-defined platforms to provide flexibility in operations and performance. Today, we are having HTS, VHTS, and LEO-MEO constellations, which are brought lots of advancements. These platforms are bringing huge capacity for communication requirements over land, water, and air. The ground segment, particularly the user segment, is very important to leverage the true benefits of these advanced communication satellites. We are seeing a lot of advancements are taking place in ground station technologies also. For instance, we are seeing a very high frequency antennas, multi-band feed systems, new encoding and decoding capabilities. Further, the user terminals need to be more mobile and more versatile. And also, it should be personally responsive. At the same time, need to be cost effective. This is very important. The growing need for the higher data rates as well as the desire of most robust link requires more sophisticated communication and modulation schemes such as 64 PSK or 128 APSK. This kind of improvement is required to improve their spectral efficiency in our communication links. The flat panel antennas are being developed for satellite communication applications. We are hoping this will be available for consumer application in the near future. This, I feel, will be a game changer in Satcom area. Today, with the advancement in high throughput satellites and ground station technology, HTS ground stations are being shared by multiple service providers, having multiple ground stations by different service providers, not economical. You may be aware that for HTS satellite to be more efficient, we need to have a gateways which need to be shared by multiple users. So this is very essential. So in this regard, already our TROI has released a consultation paper on licensing framework for establishing a satellite earth station gateway and seeking inputs from the stakeholders. This new licensing framework will certainly pave way for an inherent development and ecosystem with high technology and solutions. With the unlocking of the space sector, more number of non-government players are expected to take part in the space-based activities. These efforts will bring additional capacity, capability, and also new cutting-edge applications. This will bring more investment in space sector and boost the satellite ground station capability in India. India being a significant market for Satcom services, the downstream activities would contribute for economic growth. The talent pool in India can contribute for design, development, and manufacturing of various modules of Satcom ground segment. I am sure industry will make use of the opportunity that is opened up in India with the unlocking of space. Thank you. So with these few remarks, I will leave the floor to Gaurav to take forward with our panelists.
Thank you, Mr. Rathnakara. Thanks for setting the stage for this particular panel discussion. Let me now move to the discussion with the three gentlemen that we have on the panel. The format that we are going to go through over the next 45 to 50 minutes is that we will break the panel discussion in two parts. The first part is where each of our three distinguished panelists here will take us through what their thoughts are on the topic of satellite ground system and ground segment technologies. And the second half of the session where will be dedicated to a Q&A phase where we will have the panelists reflect on some of the new technologies and the areas of interest for this topic. So before I hand over to the panelists, let me just set the agenda that we are looking at and give my broad overview on what we are really going to talk in the next few minutes. Satellite ground segment is a huge part of the overall satellite-based communications ecosystem. It is this infrastructure and element on the ground that renders the satellite in space usable. It has been doing so over the last several years, and it continues to make the space segment more efficient, more economical, more viable. It is a mix of these active and passive devices that communicate with the satellite from the ground, starting from the antenna and RF systems, up-down converters, and the baseband electronics comprising of modulators, demodulators, routers, IP devices, as well as the NMS systems that support these devices. So how have these components evolved over time? Where are these leading us to? What are some of the new technologies that we are coming to see in each of these areas, both at the Earth Station gateway end as well as at the user terminal end? Mr. Rathnakara already mentioned a few areas in terms of flat panel antennas and as well as multi-band new encoding schemes, etc. And we're going to touch on all of these as we go through the next couple of sessions. So we have a lot to look forward to. And with that as a backdrop, let me invite the first esteemed panelist on our discussion panel here, Mr. S. Parameswaran. Mr. Parameswaran represents Planet Aerospace. He is the ex-director for MCF, which is a part of ISRO. Mr. Parameswaran is a former director, Master Control Facility at ISRO. He has successfully contributed to ISRO for more than 35 years and has successfully executed senior techno-managerial roles in 45 satellite launch campaigns by ISRO. He has done that to safely position all of these satellites in their intended orbit. Mr. Parameswaran has also now gotten into teaching, and he is a visiting professor in Malnad Engineering College in Hassan, Karnataka. I personally know Mr. Parameswaran for several years, and he has been very humble in not mentioning some of the other roles that he has taken. I know him from his Antrix days as well. Welcome, Mr. Parameswaran. Please proceed with your slides and your talk. Thank you.
Thank you, Mr. Gaurav. I would like to share the screen. Can I go on sharing this presentation?
Yes, please, sir.
Okay, I think I have some trouble, and I'll go without that also. Okay, and first, greetings to distinguished listeners, chairman, moderator, and fellow panelists. If you look at the theme of this conference, I am reminded of the famous Stephen Hawking when he said, people always wanted answers for tough questions. In recent years, Satcom industry has seen many changes as illustrated by the previous two gentlemen, which challenges the traditional thinking when the satellite was proposed to link the distant parties. In this background, any prediction about future is always risky. Nevertheless, let us positively analyze. 2020 has seen a growth in Satcom sectors for ground station and equipments. The revenue was told about 118 billion US dollars from 111 billion dollars. That means it's about 6.4% increase, and it is expected to touch the double-digit number. So the time has come now to evaluate and appreciate the ground segment to answer some of the concerns what Dr. Rathnakara has expressed in his speech. Before I move on, let me just go to the next slide, and which I just wanted to say about few words about the organization I represent. I represent an organization, Planet Aerospace, which comprises of the seniors retired from ISRO who sweated out and made remarkable achievements in their own areas. The primary objective is to knowledge transfer, and we mentor the next generation of space enthusiasts and make them as industry leaders. We have satisfying progress with this objective. Our vision is to become global consultant in the space technology. Having said that, let me move to next. The ground segment, as also even Gaurav has mentioned, it consists of the earth stations and next slide, please. Earth stations and then the gateways. And the earth stations belong the different satellites need different types of earth stations. Say, for example, a LEO satellites needs certain different earth stations, and the GEO and HTS needs different type of earth stations and gateways. And we have critical infrastructure like data processing and then the other utilities. And it can be either fixed or the mobile platform. And connection of these networks as in earth station networks, and which also interfaces with the terrestrial network. Well, being said, normally it is a very well organized infrastructure with in terms of power, the antenna sizes, the redundancies, and it is located at advantageous position for the business oriented, and also it is taken care of the physical security and the data protection security. In essence, the ground segment, the key parameters, if I can just say that, it is the availability and also the MTBF and MTBF. See, things will go wrong if it has to go wrong. And how soon we recover, it only gives you the challenge for it. That is MTTR. It is always said that your satellite services are as good as your ground segment. That is the principle that we all work together. And if you move further to the next slide, and it says that if we classify the ground segment, there are the two types of ground segment which we can classify. One is which is taking care of the satellite, which is being meant as healthy. Other one is for the intended mission purposes. See, as Mr. Rathnakara has mentioned, the satellites are nowadays becoming smarter and smarter because they become autonomous. The intervention from the ground is minimized, but nevertheless, the ground stations have to be smarter in order, in case there is a need, and this ground segment has to respond to the satellite in the most smartest way possible. So in that way, whatever the infrastructure what we have, it has all taken the modernization route. It has now taken the modern data analysis tools, and you have an optimum placement of the resources under the control to improve the availability index. And any operation that is being planned with respect to the satellite, it is ensured that the minimum interference to the payload operation that comes into picture. The other group, which is saying that whatever the mission purposes, it says that it is the intended delivery, the content, it can be grouped under the content delivery networks. When you say content delivery network, one of the prime driver for this kind of thing is the quality of service that what you can do. If you say quality of service, if you are ready to accept that in terms of your agreement, then what we need to establish, we need to have a benchmark nodes. So that means the benchmark nodes and then the content delivery networks, and then all these things will give an impetus to the sharing of resources, what we are trying to say that. And are we ready to do this kind of a sharing of resources? And if you look at it, most of the subsystems have, the next slide please, most of the subsystems have gone through systematic technological evolution. The significant being what I consider as what we have is that the IP addressable type of thing, that they can be remotely monitored and controllable. This is one of the prime requirement, or the requirement has come. And also what this thing, that device reconfigurability. Earlier, the radio receivers have to be hard coded or the hardwired. Now the programmable feature in those receivers, which gives you their software-defined software capability. So they are all coming into the software-defined radio capability in matching with whatever the software-defined concepts that the payloads are going through in the satellite. Having got that SDR and having got that IP capability, the ground station network is not limited to the physical boundaries of what we have. We can go for a wide area service network, and that is a. So even within the segment, each segment, the connections, you have an option to go from a copper cable to the optical cable and all the thing in the way that what everybody is trying to, all the technology is looking for getting that extra margin in the link that what is there. So what essentially it comes down to is that you should have a massive network resource allocator, which is a kind of a software and hardware device, which is if the network resource allocator is properly or robustly it is done, then it is possible to command the resources from a single point or the multiple points and wherever it is in there. If you move on to the next slide, see what happens if the resources are scaled up. Next slide, please. If you want the resources are scaled up, if the resources are scaled up, how does this kind of rating come? See, WRC 19, which held in 2019, lists the way to how we have to handle the short duration mission or the experimental satellites, which are of interest to the university community and also the startups. And also it gives you the way how to handle the Earth station in motion, that ESIMS. These, along with the new constellations of LEO, MEO, and high altitude platforms like drone systems, GEO missions, would encircle the user with the spectrum conflicts, what I see. And if you can adapt some of the concepts from the cognitive radio and coupled it with artificial intelligence, what we have, and we can have a very intelligent satellite access from the Earth station, which is an important aspect we can consider. If you want to improve upon the security of the communication, we can draw some of the concepts from the chaotic communication area, and that will improve upon the optical network, and that is also going to give you additional. So in essence, if I want to summarize the group, if QoS is going to be the buzzword, and grouping of the requirements under the using the QoS, standardization of the interfaces, adaptability using SDR, and the affordability and security of Earth stations will be the workable options in the near future in India. If I move on to the last slide. Okay, having established that the need for a smart ground segment, and if any of the participant wishes to enhance their use value further, please communicate to us, and contact is given there so that we can help you to realize your objective. Let us march towards a smarter communication infrastructure. Thank you. A special thanks to Chairman and fellow speakers for allowing me to take the stage first. Thank you. Over.
Thank you, Mr. Parameswaran. I think you have laid it out very nicely as to what are the key components and what are seemingly the new buzzwords and where the industry is going to go in terms of the ground segment. I will now bring on stage Mr. Jean-Luc Almeida. He represents Thales Alenia Space and Ground Segment and Services. Mr. Jean-Luc joins us from France today. And thank you, Mr. Jean-Luc, for joining us. I'll briefly read your introduction. Mr. Jean-Luc has more than 10 years of experience in systems engineering, 10 years as ground project manager, and his last experience is in the US to design and deploy Thales Ka-band solutions for aircraft internet access, which in India we popularly call as the in-flight connectivity solutions. Mr. Jean-Luc is currently the ground and services product line manager at Thales. Welcome, Mr. Jean-Luc. Kindly share your screen so that we can have your presentation.
Can you hear me properly?
Yes, we can. Yes.
Okay, good. Thank you all to invite Thales to this conference. Thank you all the previous speakers for this very interesting presentation. I will not spend too much time on this slide on myself, just to explain that after this all these years on the satellite and ground business, I see a lot of changes, and the big change now happening. Because at the beginning it was a ground segment and the satellite segment very different and independent, which is not anymore the case. And I can see at minimum two biggest components currently unlocking the business of the satellite telecommunication, and I will try to talk about those two components, which are the cloud and virtualization and the flat panel antenna for the end users. If you can go to the next slide, please. Yes, as I said, I can see a big difference regarding the satellite system from previously and now. You have the standard satellite architecture. It can be LEO, MEO, and GEO. Now we are working more at the multi-orbit level, and the next generation of the telecommunication system will be able to communicate and to use all the assets, which was not the case previously. To manage those constellations and those satellite assets, we have the ground control segment managing the platform. This ground control segment was completely independent previously of the mission segment, but with the new satellite, what we name the software-defined satellites, very flexible and dynamic, we have in mind to connect, to interface more the ground control segment and the mission segment, because the payload and the platform will be serving the flexibility and the dynamicity of those software-defined satellites. At the end, we have the ground segment, which is the use for user, including the antenna, the earth station for the feeder links. It could be in Q, K, V band. We are increasing the frequency of those feeder links just to increase the data rate that we want to provide to the satellite. And then we have the major component of the user segment for me, which is the flat panel and the terminal, user terminal, and mainly the antenna of this terminal, because the modem is not the biggest issue up to now. It's just a matter of chipset. But the antenna side is still a large topic to address, and we can see now on the market a couple of interesting products. But this user antenna will be part of the system, because it will authorize the user to connect any asset, any satellites we want. So it can be a GEO, MEO, or LEO. The only problem we face with this user antenna, it will be the cost. But we saw on the current product on the market that the cost is decreasing drastically, and this is unlocking the business for this telecommunication system with a multi-orbit. Can you go to the next slide, please? In fact, the telecommunication satellite and ground space industry must adapt, because for the newcomers, we are facing a lot of newcomers, and with a lot of good ideas, and at minimum we have to comply with the major topics of customer. The first one will be the Capex reduction. And then when the satellite operator purchases a system, you want to reduce the Capex at the minimum at the beginning. And for this, we are considering a new technology, and the cost of the technology now decreases a lot. We are considering the infrastructure, the ground infrastructure, which is very important, and it was not mentioned on my previous slide. But the ground infrastructure and the ground network will be part of the system, and the cost of this infrastructure connecting all the sites, all data center, will be also an important aspect of the Capex. In fact, to reduce the Capex too, we are using the satellite capacity to propose a ramp up, and then to start with a small business and to increase the business along the year and during the full life cycle of the satellite. And for Capex reduction too, now with thanks to those software-defined satellites, we can reconfigure the mission, and that means we can multiply the mission, which is very interesting for satellite operator, which currently are dealing with the broadcasting reduction versus the broadband increase demand. And this can be fixed by the new generation of satellite. And for sure, the ground has to authorize to use those flexibility and dynamicity of the satellite. That means that the ground became more complex at the software level. The mission segment is now taking care of a lot of payloads with a processor on board, and managing a lot of bandwidth and a lot of beams on these HTS and VHTS satellites. But by the way, the Capex reduction is the first point. The flexibility of the system also. In fact, the flexibility support the ramp up of the system. The flexibility at the satellite and on ground will optimize the user traffic, for sure. And the flexibility will optimize the mobile traffic, which is also increasing a lot since the last couple of years. Even if we struggle with the aeronautical market during those last 2 years, I think the mobility will be a good growth potential for the future. And in fact, all the ground assets have also to support this flexibility and coverage. In fact, at the end, everything is to have a better performance and lower price. The price, the gigabit price, still decreasing. And for this, we are reusing the spectrum, as a couple of previous speakers says. We try to implement lower cost regenerating processing on board. And for this, we need a complex system on ground to monitor and to use the system. And we are taking benefit of this processing to optimize the feeder link, for sure, and the waveform and data rate, as well as the user link to be resilient and to adapt the data rate of the user the weather. Next slide, please. As I said, we have a complex satellite system architecture, and we have now a couple of very high throughput satellites with a large capacity, more than 500 gigabytes, very close to the terabyte, more than 300 spots, and taking advantage of the frequency reuse, allowing us to deliver a very low capex and proposing a flexibility, delivering the right data rate at the right pace. Now we are moving to the software-defined satellite, which is the one on the right corner, up corner. Lower capacity, but much flexible and more dynamic with a processor on board, optimizing everything and allowing to reconfigure the mission over the life cycle of the satellite. And coming soon too, we have the several constellations, MEO, LEO, Ku-band, and we expect to have also a 5G constellation. We are doing some testing up to now, but the satellite with the 5G on G-Node on board is coming soon, meaning that it will provide an additional asset to the ground, providing a direct access with an handheld terminal, which is something additional to the standard DVB. And the ground becomes more complex because he has to manage on the feeder link side as well as on the user side this multi-orbit system. And we are talking about providing system what we currently name the data relay, because the next generation of satellite will also include interlink satellite, and we are expecting to see maybe sometimes a geo satellite connected to the LEO or to MEO satellite. This also will be dedicated to serve a better user experience. Next slide, please. If I will just address 2 points, as I said, which for us are key components to unlock the satellite telecommunication market, and the ground infrastructure and virtualization. As you can see at the layer 2 and layer 3, it's a major asset for the digitalization. And this is why the network between station and the data center will be important, and the cost of this ground infrastructure will be very important because it will have an impact at the capex. And then we are digitalizing the signal as soon as possible at the air station, trying to propose the air station as a service and the specificity of the access located into the cloud, and it could be a shared infrastructure. Then we want to take at the layer 4 the advantage of the cloud processing capacity to add artificial intelligence into the system. As you understand, it becomes a complex system, and it will be complex to have operator into the loop. In fact, the artificial intelligence will support the mission segment management and will support the optimization of the system. On top of that, we have, you all know that every component has to rework the way to produce, and we have to comply with carbon reduction production, and it will be part also of the cloud capacity to be autonomous, and it will take place of this carbon reduction trend. The next slide, please. Focusing on the digitalization, we have this cloud infrastructure. We try as a telecommunication system manufacturer. We try to focus on what we say the space platform layer, but starting from the bottom, we have the infrastructure layer, which should be secure or public, It will be very important now to deliver something secure during the life cycle of the system, and this is why we are not focusing on this. Fortunately, in Thales, we have other business unit taking this for us, but this will be used as a managed service. Then on top of this infrastructure layer, we have the common, what we name the common platform layer. This is the shared part of the cloud, providing all the common features, the monitoring system, cyber security system, all the data containers and all the interface. For ADN to let us working on what we name the space platform, which are the real added value development we have here, which is the mission segment or the satellite control segment. All the maintenance based on UMS, the archive and the massive processing for the data analytics and the system optimization. I will next slide, please. And I will talk about the second point, the second component we consider as a key enabler for the future telecommunication system. As many of you already talk about this, we are talking about the flat panel antenna, which is the key component. We have many techniques to build the flat panel antenna. We know the standard one with the active phase array, and the last version of the SpaceX looks very promising from the performance point of view as well as the price. But we have also what we name a digital beamforming antenna with a couple of manufacturer named here. At the end, the price reduction of this asset will be a key for the business, and for sure it will be the key component to authorize the end user to connect the multiple satellite and multiple orbit satellites. This was my last slide. Thank you all for listening to me, and feel free if you have any question. I think my email will be and my contact points will be available on the presentation.
Thank you, Jean-Luc. Thank you for those slides. I found some of those elements in those slides really interesting, and we will come back to you with some questions around some of the things that you mentioned. On the last slide, I did find one very interesting point that you made was analog beamforming versus digital beamforming. I hope we have time to discuss that a little bit in the Q&A session.
Okay.
Thank you so much, Jean-Luc.
Thank you.
Now, in the third panelist we have, he is Dr. Prasad Bhatt. He's the chairman and CTO of Astrome Technologies Private Limited. Dr. Prasad is the co-founder and chairman at Astrome, a deep tech startup developing wireless products for 5G and Satcom. For those of you who don't know Astrome is an Indian company into the field of satellite communications. Before Astrome, Dr. Prasad co-founded another successful company in the domain of visual search and artificial intelligence. He has several technology achievements to his name. He's been an architect for various technologies, including a nano satellite, a visual search engine at Streamoid, a stochastic game theory solver, a software tool for the latest 3D measurement Texas Instruments chipset. Great laurels, Dr. Prasad Bhatt, to have against your name. We welcome you to the panel. Kindly take the floor and walk us through your presentation. Thank you.
Thanks a lot, Gaurav. I hope my screen is visible.
It is.
Okay, I'll proceed further. Thank you for giving this opportunity to talk about the ground terminals. As the chair of this panel said, this is a very relevant topic for India and also the world because of the changes in the demography where we have new players coming in the LEO kind of segments. So I'll start off first with specific focus where we'll talk about only the ground terminals. those of you who are familiar with the technology would see certain value adds coming here. And for those of you who have no idea, we'll get a very good, I would say, overview of the Satcom terminals. So the first and foremost thing that I will talk about is what are the primary drivers which define what a ground terminal should be. As we all are very well aware of, cost is the most key primary driver which defines whether a terminal will be adopted by, let's say, a specific segment of users, or will it be like a mass consumer product. How it will work out, that will be primarily defined by the cost. The other major factor is the data rate. Given the advent of the smartphones since about 2008 year, the consumption of the data has gone crazy, and everybody is consuming huge amounts of data. Previously, during my I would say academic time, it used to be like we would talk about a few MBs of data for consumption, whereas on a daily basis we all consume several GBs of data these days. So that is a mass scale, and the data rate associated with that is also very, very significant now. And that is a very, very important factor that the ground terminals need to address. The other major factor from a deployment perspective is the power. How much power is being consumed by a terminal defines whether it will be limited in the audience. Will it be something which can be deployed remotely? Can it be run on a solar panel? Things like that. All of that will be drivers for defining the adoption. Sorry. Yeah, the other important factor is the SLA. To expand it, it is the service level agreement. For how much time of the year does a terminal work for you is important for customer adoption, and also for whether it can be used for critical applications, or will it be only for a general consumer, or will it be for specific, let's say, luxury segments. So that's those are the things that will be the key elements. And these factors are not new. These have been there from the time the Satcom industry has come into existence. But what has happened on top of it is that there are certain new age requirements which have gone into it. The first major new age requirement is the multi-beam architecture. Now, this is a very important thing to recognize. See, most of the deployments which are there currently, the Satcom deployments, are all talking to a geostationary satellite predominantly, except for a few cases. So, which means that both the satellite as well as the ground terminal are stationary. So there was not much need to have any kind of variation or any movement in the antenna. But in the new age case, when you have LEO terminals coming in, or you want to bring in redundancy in the GEO, where you want to talk to multiple GEO satellites, multi-beam is a requirement that has sort of flown in as a new thing. And for LEO terminals, multi-beam is a requirement, whereas for GEO it is more of a enhancement. So that is a new age requirement. Additionally, people want to use this in every possible place, whether it is on the aeroplanes, or whether it is on the ships, or whether while traveling in a vehicle on road. Now, all of these conditions, I want to just emphasize that mobility was present in Satcom for a very long time, maybe close to 35 years itself, but that was not high bandwidth, and that is not high bandwidth even now. But that is a very important change, that new age demands high bandwidth in mobility conditions. Now, that is an important thing to address as well. And additionally, because of everybody owning a camera in their smartphones in their hands, the natural process that has happened is that people are not just consuming data, but are also generating data. So the uplink is also as a demand going higher and higher than the traditional ratios, where if you maintain a ratio of something like maybe 1:10 or 1:20 in terms of capacity planning for downlink versus uplink, it was enough. So those ratios are getting skewed now. Not skewed, but becoming more symmetric right now. So this is a very important thing to keep in mind. And then now I'll go to the terminals that are there. So Traditionally, we have seen single element antennas, which is the traditional round dishes with a kind of an LNB with a horn antenna. So that kind of design is still very popular given the geo presence. However, the new age with the LEO kind of satellites, the array architecture has become very popular. Now, array architecture inherently brings in a capability where without moving the unit physically, you can electronically steer a particular beam to connect to a satellite. Now, that is a very critical requirement when it comes to LEO satellites. Now, in that array, there are again two categories of solutions that have come out. One is where you have passive arrays, and other where you have active arrays. Now, passive arrays again can be split further into cases where you use a lens or a reflector, or you basically make a kind of a fixed antenna array and you basically power it up. Here I want to highlight one thing, that the passive architecture, which is involving lens and the fixed arrays, uh, alone, as a passive alone, does not actually address the LEO very properly. It is more of a what should I say, a replacement for using just one large reflector. You have other means here. Whereas the active array, which is where you do active beam forming, either in the RF domain or in the baseband domain, is the predominant one which is going to address the LEO kind of requirements. Here I want to just highlight one small distinction in both RF and in baseband in the literature and also in several products. People talk about digital beamforming and analog beamforming. I'll touch upon that when I go to further slides. Now just going to a bit more details about the single element case. The primary thing, as I said, is that you have a baseband unit, which may be DVB-S, DVB-S2 or S2X or DVB-RCS2, depending on the case. And you have basically a single mixer element and a single power amplifier, and you have an antenna, single antenna. And then you have a large reflector. But if you go to passive arrays, the change will be this antenna will get replaced with a whole array of antenna, but still fed from the single power amplifier. And if you go to, let's say, a lens or a reflector arrangement, again the story is similar. So basically, it essentially gives you low cost and it gives you very high aperture. When in fact the active arrays are not meeting the high aperture that the other guys, this single element with a reflector can give, but they still compensate by other means. The other part is the disadvantages. These are not so great for MEO and LEO orbits, the satellites in those orbits, and not so great for mobility. There are exceptions here. There have been deployments, especially for sea condition, where people do a mechanical stability of the platform for mobility. However, that comes with a lot of overhead and also cost. So it's not the, I would say, the most favorable condition. And multiple beams is quite difficult because you cannot independently align to different angles. You obviously don't want to create multiple beams in the same direction. So that makes it disadvantageous. Going further into the RF active arrays. Now, when I say RF active arrays, this is an architecture which is very popular, where you have the baseband feeding to, let's say, a mixer, single or few mixers, and that fanning out into multiple PAs and introducing a new element here, phase shifters, going to the different elements. Now, this one is a useful architecture because electronically, by setting the right phase values to different antennas, you could steer the beam. So this is great solution for when it comes to MEO LEO. It is also good for high bandwidth mobility. It's possible to do that with this. And with certain higher cost, where let's say you introduce another baseband block, another mixer block, and few copies of other things, and then keep the antenna common as a patch through, you could potentially do two beams. It comes with a cost. It comes with more cost than this base unit. And the base unit, given that this has more electronics, if you just use whatever is off the shelf available, if you put it together, you would still end up with a very high cost compared to what you have for passive arrays or single element traditional reflectors. So that's a disadvantage. And it is even more higher cost when you go to multi-beam. And it has slightly lesser G by T. It needs certain better handling, but G by T being lesser is okay for LEO and MEO. It may be a problem when it comes to GEO. So this is a other important category of RF active arrays. Here in the literature, you would see that based on whether that phase shifter is controlled by an analog line or a digital line, sometimes there is a misnomer. People represent the digital control of phase shifters as digital beamforming. It's not a correct terminology to say, but I would like to highlight that you will encounter that literature as well. And analog control of the phase shifter is called as analog beamforming, but I would say all of that is analog beamforming, just for your reference. There is also another category where people use metamaterials, which is like the phase shift is built into the antenna. So antenna deforms in certain properties and characteristics, because of which a phase shift gets induced. So there are companies which have products with metamaterials which gives this kind of behavior, where everything else remains the same in terms of advantages and disadvantages. Moving ahead to the last case, which is the baseband. Now, baseband active arrays is something which people have sort of talked about, written down as early as even 50 years. However, it was dismissed as an architecture which is quite expensive or not practical at that time. And but with the advent of very high density semiconductors and the market drive that is going on, the baseband active arrays are becoming feasible. And in this particular architecture, you have case where baseband talks to a baseband level beamformer itself, and that feeds out to individual mixers, and it goes to individual PAs and to the antennas. Now, why would anybody want to do this? People would the primary advantage of this is that the beamformer potentially can directly take inputs from multiple baseband blocks, and it can basically create multiple active beams pointing in different directions with no other change in the hardware. So based on convenience, it's possible to create multiple beams, or say refactor the power. So which is basically translating to multiple better SLA, because you could say that, oh, this particular one does not need a higher power, will redirect that to the other. So all of those kinds of sharing and all of those design elements can be incorporated as software defined in this particular architecture. That makes it extremely attractive. However, if you just put together all the active components that are available in the market and try to realize this, it is still high cost, and it requires certain enhancements in the system. And there are several companies which have come forth in this, including Astrome, where we have come up with architectures with certain innovations to bring down the cost. This, of course, similar to the RF active arrays, has lesser G by T. So when it comes to realizing it for geo architectures, it may or may not give the right G by T which is needed for the geo, but it will definitely work extremely well for MEO and LEO. Moving to the summary slide here. This is my last slide. So we have basically talked about different categories of technologies: single element or reflector based, or RF active array, or baseband. Here, if you see, single element fails badly in the new age requirements, or single element or passive arrays, whereas the RF active array and baseband active arrays actually are faring there in those cases. And baseband particularly fares very well for multi-beam, and it also fares very well for SLA, because you can redirect power, and also you could potentially talk to multiple satellites together. It's not just a handover, but actually have the beams pointing to different satellites and aggregate the data across. So those are certain things which gives an upper hand to the baseband based active arrays. Here I want to just clarify one point. In the baseband active arrays, there are two distinct architectures. One is called as digital beamforming, which means that all of the beamforming happens literally in the digital domain alongside the core baseband logic, whereas the other one is basically sort of like a baseband intermediate frequency based beamforming. There are certain companies which have come up with certain, I would say, discrete elements and then integrated solutions also, where they do beamforming in the intermediate frequency, which is, let's say, if your carrier is something like 20 gigahertz, you might be doing this in 1 gigahertz, something like that. However, that has certain disadvantages. The digital is the one which is getting the highest attention from multiple angles because of its ease of extending once it is realized. So, to summarize, cost is a primary driver which active arrays need to actually address. That is the only cross mark which I've shown here. These are being addressed very strongly by different parties, and innovations are happening right now, and products are either just coming out or in the making by different companies globally. Astrome, in particular, has certain patented as well as patent pending innovation in this particular area, in the baseband active area, where we are bringing down the cost considerably while giving all the advantages of the baseband active arrays. So I think this is where I conclude. Thank you, everyone. And if you have any questions beyond our panel discussion that will ensue now, please do contact me with my email address. Thank you.
Thank you, Dr. Bhatt. I think as a panel, we've already talked a lot about the phased array and flat panel antennas of different kinds. So what I'll do is we've probably don't have a lot of time to talk and do the question and answers, but whatever little we have, let me jump to the key question that is driving the theme of this particular event today, which is that sharing of infrastructure is a key element that is being discussed across different government corridors, across different government departments. Earth Station Gateway also falls in the same category. And the recent TRAI consultation paper due next Monday is definitely on the minds of everyone. We all need to respond to that. So my question to the panelist is, what are some of the new technologies that can help achieve the sharing of infrastructure? Already some of the speakers in the past today have already talked about it, Krishna, Bashir, etc. What are these technologies that can help in achieving better use of infrastructure that can be shared among multiple service providers on the ground, maybe multiple virtual network operators? I have a list of items in front of me, but I will pass on the floor to each one of the panelists so that you can throw some light on that. And then if there is anything else I can add on, I will then pursue the question. So first, Mr. Parameswaran, if you can throw some light on new technologies that can use infrastructure sharing.
Fine, thank you. The new technologies, so what would fare that, it is basically for example, the connectivity has to, by connecting the compatible resources, what we will have is we will achieve a kind of an ecosystem which will be able to meet the demands of the user at an affordable level. See, as I mentioned, it is that basic with that there are now technologies available without even going to the baseband level or digital level. You have RF over the optical link itself, RF over fiber. And that coupled with the IP technology, that you will be able to share the resources in a better way. And that is one thing that which is doing that. And another thing for the sharing purposes, what we need to go is that we need to have a equitable integration of the terrestrial network which is already existing there, because people have invested a lot, and then people have they already used to certain technologies which were sitting there. So if you can integrate into the existing network in a better way, the seamless way, that is one thing that which is going to be helping this sharing of the resources which is going to come. because when you have the multi-orbit kind of a solution, that what we are trying to talk about it, whether it is a LEO, MEO, or any other platform or something, what is needed is that the IP based traffic has to be routed properly. So there is essentially that IP traffic, whatever the way that we can handle at the baseband level, at the RF level, if we can handle it at the optical level, and I think that we will be having a winning combination. Thank you.
Thank you, sir. Jean-Luc, your opinion, if you want to add anything to this question, or else I can quickly move to the next question as well.
Go to the next question.
Okay, great. Of course, I have a big list of questions, but we are already running out of time, so I'll keep it short and sweet. Let's talk about new technologies that are being talked of, and obviously the mind goes to 5G and network function virtualization. So some 5G operators in some of the advanced countries are talking of networks that would have the core network elements in the cloud, in the virtual space. Only the RAN for the last mile user access will be in the network, sort of near the user. Everything else is out there virtualized, which is now called network function virtualization. Do you see, Mr. Jean-Luc, do you see the satellite world moving in that direction? If that happens, how do you see that happening?
Yes, I can confirm that the satellite is going into this direction, and the ground too, meaning that currently we are trying to build a new satellite for 5G and direct access, because we think we have a biggest market. I saw a couple of questions regarding the market. We can consider that the geostationary satellite with a very high throughput will contribute to the digital divide, and a lot of people will be consumer. A lot of consumer people will be requesting capacity here. More now, since people are working remotely. The constellation will be addressing more the enterprise market, because in fact the constellation with a low latency and resiliency fix a lot of pain points of the enterprise. But at the end, 5G will harmonize everything, because we, as I said, we try to build a satellite with a 5G on board and the G-Node B, and providing the terminal access to everywhere over the world, and we have billions of terminals, because if we consider the chipset on this market will be a couple of dollars, we can consider if I take the automotive as an example, we have a billion of users as a potential growth for this kind of market. This is why, yes, the 5G will be unlocking a lot of vertical markets. The cloud will be part of this, because just as I said, to manage, to deliver a secure system and to have this powerful capacity of processing, because 5G also required a lot of processing capacity with the slicing, delivering several slice and several data rates. In fact, we can consider the very coming soon the 5G market taking a biggest place, I will say, on a telecommunication system.
Thank you, Jean-Luc. I wish I could have continued the same question for Dr. Bhatt, but let me ask a different question to Dr. Bhatt as well. Dr. Bhatt, most of your presentation was around flat panel antennas, different kinds of arrays, etc. I have a very interesting question from the audience. I will turn to that, but the broad question is, are we, with all these technology that we are talking about, are we talking that a satellite consumer, whether it is a DTH consumer or a enterprise customer, will soon have a flat panel antenna? How long are we, how far are we away in terms of time and mass production, etc., for a flat panel antenna for a geostationary satellite? That's question number one. And in the same vein, the question from the audience is, you say, everyone says there's a huge demand for flat panel, low cost terminals. Are we talking low cost flat panel antennas in the first initial phase for enterprise or for consumers? So rather lengthy question, but all yours.
Yeah, I think The point is very clear from there, so I will directly get to it. So the most important thing to understand is that the flat panel architecture, despite all the what should I say benefits that it brings in, the cost is the primary one which will define how it will get adopted. So from the way the landscape, if you see, for example, the terminal that Starlink has come up with certain cost, which I believe everybody is aware of, and if we look at that and refactor its G by T, for instance, which is a very primary thing when it comes to geo satellites, you would see that the cost goes up significantly, even if just consider that, which means that it is likely that it will get first adopted in two segments. One segment where it's an enterprise market, where it is, let's say, serving a particular group of people. It is not like an individual case. And slowly, maybe in a matter of maybe 3-4 years to about 5 years, it is likely that cost of the silicon is going to crash. The most critical factor there is how well can we integrate all of the different elements that come in the flat panel antenna into a silicon. So the more integration that is achieved, the cost will crash down accordingly. So that is the primary one. So it will go in phases and get adopted. The final consumer, for instance, if you consider, let's say, the Starlink terminal itself, the cost for a consumer right now is exorbitant. That also will crash in about 3-4 years once the silicon industry changes the integration part in that. So I hope
Thank
that
you.
summarizes
Yeah.
the answer. I
Sure,
think
thank you.
Parameswaran sir.
Yeah, Parameswaran sir, one last final word. I've been told that we need to wrap up the session, but one last word from you, and then I will ask Mr. Rathnakara to have his final views on the session. Yes, Mr.
Coming
Parameswaran.
back to the flat panel antenna, before it comes to the user segment, I just because we need to look at it the side lobe levels, because then only it will be, because the moment you have the highly now the antenna characteristics normally the main beam, there are the side lobes. Unless you handle the side lobes properly, the user community will not be able to utilize this flat panel antenna in a way. So now we have to move on to the world where the side lobe level ratio, that SLR, has to be the defining factor technologically. So ITU is giving certain restrictions. Unless that is handled, then it will be coming long time before it comes to the consumer market. Thank you.
Sure. Thank you so much, Mr. Parameswaran. Thank you all the panelists. I will want to hand over for his final comments to Mr. Rathnakara, who is the session chair, sir.
Thank you, Gaurav. Actually, we had three eminent panelists today in the ground segment area. So we heard from all the three of them. That is, I will quickly summarize. Actually, today we had a session on this ground segment where we could look at the key components which are defining this ground segment, and also the requirement of the flexibility of these ground terminals. That is, in the futuristic antennas need to be more flexible and reliable. This is where is the requirement, what is projected by one of the panelists. And also new trends. In fact, the satellites are becoming more complex, and utilization of these that is beamforming and everything is already being done in the satellite technology. And also the gateways which we are planning to utilize for the high throughput satellites, as Gaurav was suggesting, that sharing of the gateways, this is one of the buzz now word today. So people are looking for that recommendation also. So this is also one of the area where we have to give our comments and give so that the per bit cost will come down tremendously for satellite usage, so that we can compete with the terrestrial network. This is where is what is required. And one more thing is that the flat panel antenna, this is maybe a few years down the line where we will be able to adopt for the user community, but it will be a game changer. Definitely it will be a game changer. And also we have heard very in depth for the array antennas details. So I thank each and everyone for all the three panelists for giving their insight into the ground segment, whatever is what we have discussed today. Thank you.
Thank you so much.
very much.
Sapna ma'am, yours, please.
Yeah, thank you very much indeed, sir. We thank our eminent chairperson, distinguished moderator, and all the eminent panelists for their contributions in this wonderful interactive panel discussion session that we had. And ladies and gentlemen, we now close the proceedings of panel session 1. And to move on to the panel session 2, I would request everybody to go to the agenda and log in again from there for panel session 2. Thank you very much indeed. Once again, signing off from here.
Thank you.
Thank you.
Thank you. Bye. Thank you. Bye.